19. This is killed, and this guy, remember that's a plus 2, okay? Minus 1 is equal to b, so b is equal to 1. Okay. Let's go ahead and kill b by putting x equals negative 2. To do that, you get negative 36 plus 19 equals negative a. Am I right? Yeah, and this guy gets killed, and so a is equal to, this is what, negative 17, so a is equal to 17. Okay, so your final answer is not this, it's neither a nor b. Your final answer is going to be 2x cubed minus x squared plus x plus 5 all over x squared plus 3x plus 2 is equal to 2x minus 7, okay, 2x minus 7 plus 17 over x plus 2 plus 1 over x plus 1, okay? This is your final answer, not a and b, okay? This is x plus 1. That's a 1, okay? And then you can check that this is right by doing your graphing process, all right? And I'll leave that to you to complete. Okay, check. Okay, step 4, check. Make sure you've got that on your graphing calculator. There's still several more examples to go. I guess there's 3. You know, is there a 4? There's a 4, and goes on and on and on. And then there's homework for you to try. Okay. So I'm here right now on example 3. This is a special example with repeated linear factors. Okay, and I'll explain to you what I mean by that. So take this down, I'll pause here for a minute. Okay, so repeated linear factors. So down here the denominator has a linear factor of x minus 1 times x minus 1. That's why it's called repeated, it's happening twice. To do this is a very specific way of doing it, okay? Remember what I told you. If the rules say, and again, go back to page 501, read the rules, the rules basically say that if the denominator is a linear factor, then the numerator is a constant. If the denominator is a quadratic, then the numerator is linear. If the denominator is cubic, the numerator is quadratic, and so on. So in this example here, it kind of really violates one of the rules. The rule that it violates is that if you really look at the denominator here, it's quadratic, but yet the numerator is a constant instead of a linear. So that's a specific thing to do with repeated linear factors, okay? With repeated linear factors. So please make sure you follow that, okay? All right, so let's go ahead and find a and b again now. We're going to multiply everything by x minus 1 squared. So on the left-hand side, I get 2x minus 3. On the right-hand side, I will get a times x minus 1 plus b using the killing method. Okay, so I kill a by putting x equals 1. On the left hand side I get 2 minus 3, which is negative 1. On the right hand side this disappears. Negative b is equal to negative 1. Okay, b is equal to negative 1. If I want to kill b, unfortunately I can't quite kill b, so I got to use some other technique, and I'm going to kind of do a mix and match. Okay, so now I'm going to do equating coefficients, which is the book style. Okay, equating coefficients. Okay, so equating coefficients of let's say, what do I want to do? Just x. Then on the left hand side the coefficient is 2, on the right hand side is a, so a is equal to 2, and I got it. So you can see that sometimes the killing method doesn't work, and so you use things that are down in the book. Okay, so use the mixture of both. So your final answer should be, let's get red out here, should be 2x minus 3 over x minus 1 squared is equal to 2 over x minus 1 plus, or rather minus 1 over x minus 1 squared. And we can check this algebraically if you don't want to do it through the graphing calculator, is by combining these guys, and I get 2 times x minus 1 minus 1 over x minus 1 squared, which is 2x minus 3 over x minus 1 squared, which is what my left hand side is. So that indeed is correct. Okay, so this is how you handle repeated linear factors. Okay, next example. Example 4, unfactorable denominator. So this is not factorable. Snip. Here we go. Okay, so here's your example where the denominator is not factorable. It's not factorable. So the rules say you need to split it up over the factors of the denominator. So one factor is x, the other one's x squared plus 1. So since the denominator is linear, the numerator is constant, the denominator is quadratic, the numerator is linear. Okay, again, rules, page 501. And then it's the same process, finding a, b, and c. So on the left hand side I will get x squared minus 1. On the right hand side I get a times x squared plus 1 plus bx plus c. So you can see that you will not be able to kill a because there's no value of x that's going to make this guy 0. Okay, no real value of x that's going to make this guy 0. So killing method for a is not going to work. Can we use other killing methods? I guess we could. We could kill b by selecting a 0 for x. So let's do that. Okay, let's do that. This one's going to be a little bit more involved. You're going to get equations in a, b, and c that you'll have to solve. Okay, by whatever methods that work out easy. You don't just have to use things to kill a. I could, for example, use x equals 0. Okay, so let's do that technique. Okay, if you set x equals 0 on both sides, the left and the right. On this side I get minus 1. On this side I get a plus c. If I put x equals minus 1, then I get a 0 on this side. What do I get on this side? I get 2a minus b plus c. Okay. And if I put x equals 1, notice I'm choosing some simple numbers here so that I can do the math. This gives me a 0 equals, this is going to be 2a plus b plus c. So you can see that there are 3 equations.